Same water, two white solids. One vanishes, one refuses. If you understand why, you've got a key that unlocks a lot of inorganic chemistry. Dissolving, for ionic solids, is basically a tug-of-war between two grips. The crystal's grip and water's grip. An ionic solid is made of charged particles, ions. Positives and negatives arrange themselves into a repeating pattern. That pattern is stable because opposite charges attract. Crystal grip is simply how hard it is to pull that pattern apart. In chemistry, we call it lattice energy, but you can treat it as lock strength. A tighter lock is harder to break. Water has its own grip. Water molecules are polar, so they orient around ions and stabilize them. Think of it as a water jacket around each ion. That stabilizing wrap is hydration. Here's the plain language version. Dissolving is an energy budget. You pay to break the crystal apart. You get paid back when water wraps and stabilizes the ions. If the payback is big enough, dissolving becomes favorable. And there's a third factor people usually skip, the mess bonus. When ions spread out in water, the system becomes more mixed, more ways for the particles to be arranged. That more ways to be often helps dissolving happen, even when the energy budget is close. So the practical rule is, dissolving is more likely when water as grip and the mess bonus together can beat the crystal as grip. You don't need numbers. You need the direction of the tug. What controls crystal grip? Mostly distance. Smaller ions sit closer together in the crystal. Closer charges pull harder. So all else equal, smaller ions usually mean a stronger crystal grip. What controls water grip? Charge density. How much charge is packed into how little space? Higher charge and smaller size pull water molecules more strongly, so hydration is stronger. Table salt dissolves because water can stabilize the separated ions well enough, and the mixing bonus helps. The crystal grip isn't trivial, but it's not unbeatable. Now look at kettle scale. Certain ion combinations form crystals with a very strong grip, often involving doubly charged ions. Water can stabilize them up to a point, but beyond that point, the crystal becomes favorable again, so it deposits as a solid. One more everyday piece, saturation. Dissolving doesn't mean infinite capacity. As more ions enter solution, the balance shifts. Eventually, dissolving and reforming the solid happen at the same rate, so it looks like it stops. So here's the tool. Charges first, sizes second. Then ask, is the crystal grip likely to be huge, or is water likely to stabilize the ions strongly, and does mixing help? This won't predict everything, but it makes the subject readable. Which grip do you instinctively overestimate, the crystal's grip or water's grip?